Good morning, class. Welcome to the online classes for physics of class 7th. We are going through the chapter that is mechanical properties of the solid. In the last class, we have completed the topics of your SLR or refresher or any NCERT book also. So after that, we will be seeing this in these 2 days, the revision for the chapters, because day after tomorrow, I think our result distribution will be there. So no video upload on that day. I think so. We have to complete this in this week itself. After that, we will be starting the second chapter also. Before term to portion, we have to complete it faster. So that's why we are doing it this. We have to complete it in the videos itself. So here I am going to start the revision. So through this revisions, you just see the topics and try to note it. Because now I think you are of not that class 8, 9, 10 students, like we have to give you the notes particular that this words you have to write, like this you have to write. So you can see the video and you can write the problems also according to that, right? So here I am giving you the definitions pattern. So you can just write the topics also, points, the headings also, that will be useful for you. And if you are having doubt, you can comment down, okay? So let's see that before going to stress, already we have seen that solids and its mechanical properties, that we have seen that every body is not that much elastic and not that much plastic also. So every body has a elastic behavior as well as the plastic behavior. Like that, when we apply a force on any object, the object get deformed. That means its size and shape will be changed. So that is what the deforming force. If the force is applied and there is a change in the size and the shape, then that force is considered as a deforming force. And if you apply a load also, then also the body size and shape changes. That means tension force is also there to change the size and the shape. So every force is trying to change the size and the shape of the body. Similarly, if I talk about a restoring force, the force which is trying to regain back its original size and shape, which is helping them to regain its size and original condition. So that is considered as a restoring force. Like if we are stretching a rubber band, that means that solid is elastic, because when we leave that force with which we are trying to stretch it, if we are leaving it, that means it's regaining back its original size. So that is what the condition, that it is regaining back, that is considered as a restoring force. And the object which can regain back its original size and the shape will be considered as an elastic object. If the object is not able to deform also when we are applying a deforming force, or if it is getting deformed but then also it is not observed, and it can regain back its original size and shape in seconds, which cannot be seen. So that is what the plastic behavior of that object will be, and the object will be considered as a plastic object. So a force can be of two types, that was deforming and the restoring force. But we know that force is applied evenly on the surface of the body. But if we talk about the applied force on a particular one point of unit section area, that was force upon area, was considered as a pressure. Here we are talking about stress. So stress is what? That the area through which you are applying the force, the area of cross section will change. But here stress is the reactional force of that deforming force. So reforming force, that we are trying to change the size and shape. So we are applying a force on the object, but that unit cross section area, the point will try to regain. So the point when we are applying, like if you are just trying to pluck, or you are trying to make a pinpoint on any object, what will be happen, that you are trying to prepare, or you are trying to make that object to make pinhole in that, right? That means you are applying the force on the object, and that object will get a small hole. But whether the area of the other objects get hole, no. So we are applying the force on that small pinpoint. So that is considered as a stress on that point. But the force is not the stress, it is a deforming, because we are trying to deform the object. But the reaction force, because every force has an equal and opposite reaction. Opposite force will everywhere it will be acting in the opposite direction. So every force will be in the opposite condition. So we are applying this pinpoint, then the other opposite force will be acting in its opposite direction. So that opposite restoring force will be considered as stress. And stress is given in the letter sigma, and it is a ratio of the force per unit area. So it is given as force upon area, and since I have seen that it is denoted by the letter sigma, and its unit is Pascal. Since the scientist Pascal gave it, so it is named as Pascal. For force it is Newton, for area it is meter square. Okay. Now we will be talking about strain, but before that we will be seeing the types of the stress. Types of stress, mainly the two types of stress is there, that is normal stress and the combined stress. This normal stress can also be said as a longitudinal stress also. This means that when we are applying a force, then there would be a change in the size and the shape, that is due to the deforming force, and the opposite reactional force will be acting, that is stress. So when we are applying to change any size and the shape of an object, if there is a tensile means or a compressive stress, they are considered as a normal stress. Normal means if object is like this, you are applying the force in the perpendicular direction. This is what the normal stress is applied. So, but this is considered as a longitudinal stress. Longitudinal means there is a change in the length. If there is a change in the length due to stress, it is considered as longitudinal stress. But here the two types of stresses in that longitudinal stress or the normal stress are, first one is tensile stress and the second one is compressive stress. So what does tensile stress means? Like if you are applying the force in this condition, that means the object will get stretched out. That is was the tensile stress, means the length is increased now. Let the increased length be del L, then the change length will be L plus del L. And if you talk about compression, then the force will be changed, and now the force direction will be like this. So the object will get more smaller. So that means there is a change in the length, but the length is already changed with del L. So it is decreased. So the decrease in the length will be considered as for the compressive stress, and increase in the length due to that stress will be considered as a tensile stress. Tension means you are providing a tension on the object due to the load and the length is increased. Now combined stress. Combined stress is nothing else but it's telling about a directional stress itself. That shear stress means like this object is there and you are applying any tensile stress to it. There is a bending on the surface, that means it get bent. Okay. So there is a change in the angle, that is theta. Now it get bent. Like if you are having a book also, then this book is getting folded by one side, then that is considered as a fold in that book will be considered as shear stress. This is what the force will be. There will be fold in some pages, and that pages fold will be considered as a tensile stress. That means the change in the fold or the due to the stress will be considered as a shear stress. And if we talk about torsional stress, torsion means there is a twisting stress. Twist means like if you are applying, you are having a thread and if you are having a pendulum, because in the practical time also I told you that along with the simple pendulum there is a torsional pendulum also, that when you are giving a stress on this wire get twisted, because it get twist with an angle theta, means it getting twisted and again regain back to its original size and the shape. So that means they are getting twisted with an angle theta, that is torsional stress. Shear stress was an angle of theta where it gets bent. So bending or folding is considered shear stress. If you talk about torsional, then it is a twisting. So here you can see the definitions also. Just take the screenshots and you can just see what the points are. There also you can write in your notes also if you want a shortcut for your notes. If you are preparing for your competitors, then if you are talking about your normal exams and all, then you can just see your books and study. So normal stress, we already know that the resisting area perpendicular to that applied force. We already said that the area perpendicular force will be applied and that area will try to regain. So that is the resistive force, the reaction force of the applied particular force. Tensile stress, we already know that the stress on any body when it is subjected to equal and the opposite pulls, we are pulling that object, means there is a change in the length but increase in that length will be considered as a tensile stress. If you are talking about compressive stress, means you are pushing with two equal and opposite forces, then there is a decrease in this length and this pushing area will be taken as its compressive stress. Combined stress, shear stress, like forces are parallel, that means tangential force, means you are applying the force in the tangent conditions, means you are applying force in the tangential direction. The force is parallel to the area, and the shearing stress means there will be change in an angle. So when you are applying to the compressive or the tensile stress, we are talking about longitudinal condition, but or a perpendicular. Here you are talking about a tangential condition. So the force which when applied in the direction of the tangent, there is a fold or the bending, that is considered shear stress. If you are talking about torsional, when there is a deformation in the shaft, here it is written circular shaft, but if you are talking about a wire or shaft, means when you are suspending anything on the simple phosphor bronze wires are there in your mechanical works of machines, so the shaft will be continuously means it is rotated, so that change in the twisting of that wire will be considered as a torsional stress. This was a kind of stress, like tension stress you are seeing when you are trying to increase its length, means you are like stretching it, so there will be breaking point, so that is tensile stress. If you are compressing it, then also there is a change in the molecules, that is compressional stress. Shear stress, when you are trying to fold or you are trying to move that object in the direction, then that will be considered as shear stress. Strain, when a body is subjected to some external force, there is a change in the size and the shape. You have already seen that stress is applied and there is a change in the size and the shape, and this ratio of the change in the dimension to that of its original dimension is considered as a strain. Strain will be a dimension in the unitless quantity. Types of strains, if you talk, then tensile strain, because when you are applying a tensile stress, then there will be a change in the length. That change in the length particular to that of original length will be considered as tensile strain and the compression strain. Volumetric strain, that when you compress an object perpendicularly or a perpendicular force is applied, there is a change in the volume, but when it is compressed, then a change in length also, and when sometimes a change in the volume is also there. That change in volume and with ratio to that of original volume is considered as volumetric strain. Shear strain, that is the fold or the bending we have seen, that due to the shear stress, then that change in the theta, there is angle fold by the original fold of theta, is given as a shear strain. So tensile strain, that means ratio of the increase in the length to that of the original length of the body, is given as tensile strain. Again, the decrease in the length to that of the original length of the body is given as compression strain. Volumetric strain, change in the volume to that of the original volume. So here you can see the diagram for that of the tensile strain and the compression strain, and this is what volumetric strain is. Shear strain, I already shown you this diagram, that when you are just trying to fold but the basis does not change. So tensile strains are considered positive in case of producing increase in length. Compressive strain, then it is considered as a negative because there is a decrease in the length. So this change in the theta will be del theta upon theta, that will be shear strain. Now the Hooke's law, but we have seen that in the book, according to a book also, that Hooke's law is directly proportional to that, what it tells, that stress is directly proportional to that of the strain. This was the first line for your Hooke's law. And it is also said that in the elastic, within the elastic limits, the ratio of the stress and strain is constant. That means stress and the strain will also be constant to each other if you take its ratio. That means they are directly proportional to each other. Both means the same, but they have told this. Okay, so what we can say, that the stress is directly proportional to strain, and if you take the ratio, then some constant will be there, and that constant was given by y. That is, firstly it was given as modulus of elasticity E, but it was given by Young's, so it was given as Young's modulus y. After that we have seen, if you talk about the volumetric, then it is bulk modulus B. If you are talking about shear stress, then eta used for the theta one, that bulk modulus of elasticity, Young's modulus of elasticity, and shear modulus or modulus of rigidity. So different modulus also come after this Hooke's law. So Hooke's law tells us the ratio of the stress and the strain will be constant. What is elastic limit? That means the property of a body that it undergoes to the deformation force and get regained back to its original size and the shape, and that body is said to be the elastic. And the deforming external force, after the removal of that deforming force, then also if it is regaining back in size and shape, that means they are elastic, and its elasticity, that property is said to be elasticity. And if your removal of external force is there, there will be a limit till which it will behave as an elastic. After the removal of that deforming force, if it get plastic behavior or it get break, then it is elastic limit. Until that only we can apply the deforming force without the breakage or without the change in the size and the shape. Okay, the Hooke's law we have already seen. This is what the stress and the strain graph, like we have already seen that in the Hooke's law, according to it, stress and the strain are directly proportional to each other. So this graph you just imagine along with a rubber band or any object that which are elastic or any other object, that when they are getting applied force, this you can see in the x-axis, that is strain is given, in the y-axis stress is given. In some in different exams, and stress and the strains are also reversed out, so the graph will be just reversed in the direction. So stress and strain here given it, that when you apply the stresses, the strain is also changing and they are directly proportional each other. How much the stress you will be providing, there is the dimensions change is also along with that. So this is what you can see in the elastic region and the plastic region, that when you are applying the stress, the strain is also continuously increasing. Till this point, what we are seeing, that till this point the body is acting as an elastic point, means the body can regain back if the deforming force is removed. So when you are applying the stress, there is a change in the strain, there is a change in the size. So if you're talking that if the stress you're applying, if changed it is, then the bodies can regain back to its original size and the shape. That means they are in the elastic limit now. Okay, so the point comes from where it cannot get regained back its original size and the shape. That point is considered as an elastic or the yield point. That means after that, if the deforming force is increased, then that cannot be regained back its original size and the shape. After this, what you can say, this is the point where it is now also it is trying to regain back, but it will take a time. And now after this, when this point is still beyond this, if the reforming force is applied on it, what it will reach to the plastic region. And this what plastic region means, that the point where it cannot regain back its original size and the shape. And the point will come where the breaking stress will come, that after that if you will apply the stress, the point will get break. That means the rubber band will get break. So the point will come, this is what the fracture point. That means if you are trying to remove the deforming force also, but it get already broke, that means it became perfectly permanently elastic object. So that point will be considered as your fracture point. So this is what the points for your fracture condition, or is a stress and strain graph. Okay, so in these 2-3 days, coming 2-3 days, we will be trying to see all these topics which we have seen already in according to your book. So with these images you can be more clear about the chapters, because concepts are more important. After this I will be sending you the PDFs for your questions. You can try to solve also, because it is already given as Aurorus and all. Mostly the questions are used to be coming by your Young's modulus, bulk modulus, or the modulus of rigidity. So you can try to solve it by your sample papers. You can just even search in the Google or in the YouTubes also. You will get the different questions, because no one can give you an extension for any questions, na? They can be given in the limit itself. So try to extend it and try to make your own self study, and try to assume that you are containing more exams and you will be trying to give more questions also. Okay, so thank you class. So in next class we will be seeing some more topics of this chapter.